Hello everyone, this is Maurizio, editor-in-chief of Power Electronics News and Embedded.com. I am here in Milan at NI Days, and I have the pleasure to be here with Frank Heidemann, Vice President Technology Leader at NI Emerson. Hi Frank, thank you for being here.
Thank you for having me. Yeah.
Everything is good?
It's wonderful. It was great NI Days here. So we're kicking off NI Days globally here in Milan. That's the first NI Days of 2025, and it's going to be a great series. So we had a good day, yes.
Good, thank you. So let's talk about, so I have prepared different topics to talk with you. Let's start with infrastructure and reliability. So we talked during Electronica, during the latest Power Up in Milan about reliability, wide-bandgap. So we are seeing a market that is trying to go ahead in terms of electric vehicles. So how do you see wide-bandgap for electric vehicles? So are you seeing an increase in terms of gallium nitride, silicon carbide devices for electric vehicle? How do you see wide-bandgap devices for electric vehicles? In terms of so replacement, we know that people would prefer IGBT because it's a story, of course, and 2032 IGBT will enjoy the 50th anniversary, I guess.
Big anniversary, yes.
A big moment. So how do you see this part of market?
So that's a big question. It's a good question, actually. So the silicon carbide and gallium nitride, so the wide bandgap devices in the automotive world is really changing the game. We have a huge increase of efficiency in these inverters, but not only in the inverters of the drivetrain, we have also like the charging infrastructure, the infrastructure in field, the energy where we're getting from the energy. All these inverters, they need to be more efficient. So silicon carbide and gallium nitride, they have a big advantage. On the other side, what we see right now, it is a challenging market. So till today, most of the cars are IGBT driven, even if silicon carbide is a big thing in one of the major players, but even on very established car companies, they're still using in the day, on today's cars, a lot of IGBTs. So there will be a growth of silicon carbide and gallium nitride in the automotive world naturally, since they're moving from IGBTs and silicon-based technology to a silicon or wide bandgap technology. And that will increase efficiency. At the same time, it's pretty hard, but the IGBT and silicon market, the growth in the market is almost as big as the complete silicon carbide market right now. That changes right now. It's shifting towards silicon carbide, and silicon carbide grows faster than the growth, or the market is bigger than the growth of IGBTs. But IGBTs and silicon is still a huge part of this technology and of this market. On the other hand, we see the demand of efficiency increase in the market. And this is not only drivetrain. A special field of that, and this is where gallium nitride really plays a big role, is in charging infrastructure. So energy infrastructure and charging infrastructure is really driving gallium nitride in the future, and we will see a lot of application. Even when we see right now that gallium nitride really grows even in voltages. So we have gallium nitride now 600 volts, we will see 800 volts and more, and this has such a big advantage in pricing that we will have a growing market of gallium nitride.
So OEMs, automotive OEMs are becoming more tech-driven. So what does it mean? I mean, embedded solution, embedded technologies, sensors, power as well. If you would combine autonomous car with electric car, is a big challenge in terms of integration.
System, yeah.
How do you see this require? So what challenges do you see in integrating all of this technology, because we have to take care in terms of safety, in terms of reliability. So how do you balance any challenges?
So first of all, it's a big shift, as you said, right, from a mechanical system to a complete, fully electrical system, and that has a lot of effects in a car. It makes the system, from an electrical perspective, so much more complicated. And it gets so much easier on the mechanical side. So that's for sure. On the other hand, there are issues with safety, there are issues with reliability, but purely and clearly, the automotive world is always safety first. So there's actually a balance between safety and reliability is pretty hard to make. So safety is always first, but we need a lot of reliability. And it comes into play much more since these electrical systems are really dependent on reliability, right? If you, like 10 years from today in the past, if you're, let's say, radio in the car broke down because it's not reliable, nothing happens, right? Because the car still drives. It's a mechanical system. Today, if your electrical system breaks down, there is nothing in your car what you can use anymore. So this is a very important topic where we have a different focus and a different view on reliability on electrical systems in the cars. And on the other hand, the complexity of these systems are dramatically increasing. You have entertainment, then is navigation, and then is control of your system. There's the drivetrain, there's a charging system. If you look out in the market right now, there is one company with a lot of problems in their onboard charging, and they cannot supply the demand just because of reliability. So reliability is an issue on customers' demand, and yeah, you're basically ability to serve the customers' market demands. So we see a lot of more complexity, and this is really where our platform can help a lot. So we can test from the powertrain to onboard charging systems, to the radar and the infrastructure, to cameras, to LiDAR, infotainment, and all in one system. And this is very important because we have now these cars where anything is integrated in one core domain. There's most of the time one big control unit controlling all of this. So the complexity on test system side is also increasing dramatically. And we're not talking about AI today, right? This is coming next for us.
Indeed. Let's talk about AI. So we know we can have the best AI algorithm. So everyone is talking about AI. I'm talking power electronics sometimes. So using AI is also related to manage the power, because without power you cannot have any algorithm, AI, that can analyze faster your data and so on. So what your thought about AI for test and measurement, AI, power electronics? So what do you think about AI in general?
So AI in general is really a paradigm shift in the technology world. I mean, it's everybody's world, right? Anything in what we do today manually will be in the future AI, and somebody uses for doing their email, others writing code with it. So there's a huge shift of that. And this is also in test and measurement. So engineers in the test and measurement world, they will be more relaxed on very repeatingly actions and jobs, what they need to do, analyzing data, for example. This is a place where AI can really help, and where we're really looking into our platform, how we can help the engineers to do this. On the other hand, as you said, AI has a energy demand, and the energy demand is really, really big. Just to train a GPT-4 model, it uses the same amount of energy which have 150 American households over 1 year. And this is just the energy you need to train the system, not to drive the system. So this energy needs to be produced, where power electronic and power semiconductor comes in place. Then it needs to be sustained, so you need to supply these systems. And even in the GPUs and the big server farms, you have internal power supplies, where you transform energy from high-level voltages to very small-level voltages with high currents. So basically, power semiconductor and the efficiency of power and semiconductor really plays a role from the very beginning till the very end of the user. And what we, I think, underestimate is the dramatically fast growth of AI application. If you look into these AI applications today in the market, there is not a single day where you don't see a new application coming up for whatever reason and you can imagine. And these applications running on server farms, and these farms needs to be built. And we guess probably that we have in 2030, 10% of the complete electricity energy in the world will only supply data centers for AI. So the growth from today data centers is roughly 1.8%. That's the common guess. It's growing 5 till 7 times within just 6 years. So it's an amazing energy demand. And this is where wide bandgap technology really plays a role, because that is increasing the efficiency from wind turbines, solar energy, wherever the energy comes from, till the point where the GPU gets its current on a very low level, and where we need all this efficiency, not to produce heat, but produce output of these huge AI machines.
So in practice, you have a population of millions of electrons, and you have to take care of single one.
Absolutely correct, yes. Every single one, count them.
So let's talk about infrastructure, energy. So energy is undergoing a significant transformation in terms of renewable energy, solar. So we hope that we can have even more solar and renewable energies, energy. the process we need to energy transformation, energy generation, conservation with energy storage
Yep.
in practice. So what about test and measurement? So NI is providing different solution in terms of energy testing. So any updates?
Well, absolutely. So we have multiple solutions for power electronics and power semiconductors. So what we really are in the market from front-end testing of power semiconductors, back-end testing power semiconductors, doing reliability tests of power semiconductors, and then we go to power electronics where we test power electronics, inverters, or even battery systems, modules, or even complete packs. So this is what we have on our solution path, but we're looking into really and looking for solutions where we can put more in the platform. So it's more a drive towards making it more granular and easier to use for our customers with our platform. Because as you said, it's on one hand, we generate this energy, but on the other hand, we need to sustain the energy, we need to save it somewhere when, we don't need it and the wind is there, so we need to save it somewhere. And then we need to have a bidirectional grid as well. So every car will be a battery and will be used as a battery, and we supply back and stabilize the grid in the future. So as you can see in this very complex system of energy transformation, storage, back and forth, you need a lot of testing to make sure these grids are on one hand controllable and on the other hand stable. And this is what our platform can test, from very algorithm top test on software and embedded down to power, where we can really test like these infrastructure, single pieces like a charging station, bidirectional charger, onboard charger, inverters, or even power semiconductor, and making reliability tests.
Yeah, so with the advent of electric vehicles, you have to take care of the fluctuation of a grid. That is important.
Absolutely, that's
as
very,
mentioned.
very important, yeah.
In conclusion, Frank, just last one. So we are going to reach net zero goals for each industry. So this is the direction. So what message you would like to give to our audience in terms of net zero goal in the industry?
Well, the industry is big and there are multiple industries to look in, but what we really need to do is increasing the efficiency. It's an illusion to say we save all this energy with more and more people coming on that world and more energy demand. We had it a minute ago, we talked about AI, and this technology, AI, is increasingly demanding energy. So the idea of reducing the energy demand is probably an illusion. So the only thing what we can do is increasing the efficiency. Mm-hmm. And by increasing the efficiency, wide-bandgap materials and new materials really playing a big role in this game. Gallium nitride is a huge, huge technology jump, and the grid technology and charging technology that really helps us. And this is the point where we, as the community of power semiconductor and power electronics, really bring a huge value to that target of net zero. Because I think that basically power semiconductor and power electronics is the only technology who effectively can change the world and can change the efficiency and the waste of energy. And this is dramatic. It's a big challenge for all these engineers in this field, right? But I think we need to tackle that challenge and make it as good as possible. If we just save 2% of energy by making it more efficient, that's a huge amount of energy globally, right? Yeah. And this is what I'm seeing forward and what I really want to see in the future is that we can help with the platform, with the technology, with our test systems, what we provide to the market and to the customers, that these customers can make their products much more efficient and much more successful to reach this net zero target.
I totally agree. Power electronics and wide band gap.
Absolutely is the key. I completely agree.
Thank you, Frank. Thanks a lot for your time. Thank you.
Thank you.